Good evening, folks. Going to do our little live stream of assembling our circuit board for the Haunted Pumpkin tonight. And the boards arrived today, so I'm going to do some assembly today. So this should be exciting and informative. And if this works well, keep an eye out for an upcoming workshop to build your own Haunted Pumpkin circuits. So, as you can see here, we have everybody's favorite board. Some of you may have seen us design this board, a little purple circuit board that, let's try to get it out where it's focused here. This is our, from Osh Park, who provided an okay printing service. I don't know if I'll be using them in the future, but they got us by for now. So we want to start with assembly. In just a moment, as I turn my soldering iron on, it's got to heat up. So we've got a few components today, and I'm going to start with the simplest, stupidest components first. These are the ones that are going to be hard for me to mess up. That's these little screw terminal connectors. They solder onto the board, and we'll solder, they've got a little screw there that clamps down this little metal block, and we'll use that to attach to wires like our battery terminals here. We'll use these because they provide a good secure connection. A moment. A preparation step was missed, and I must amend it as I root around in my workshop. I need an acid brush. And most of you watching this live stream, you really aren't going to be able to hear much or see much. The audio quality is going to be bad because my workshop is too far away from my network router. So off camera, I am opening up my flux. And even if you can't hear this session very well, I am recording this. It will go to YouTube, and you'll be able to watch the full thing. So what I'm doing right now, let me do this on camera. This is a little bit of flux. This is actually plumbing flux, and it's not maybe the best thing to use, but it's the flux I have. So I'll try to find a better flux for electronics for our workshop, so you're not using this stuff, which is kind of nasty and leaves a horrible residue. But it's also really effective. Okay. If you look at our board here, you see all these square pads? Those are where these screw terminals go. And we always set the screw terminal so that the little block portion that you see there, that's to the outside. And let me position all four of these. Three of these, there's only three. And with these printed circuit boards, we do all of our soldering on the bottom side. I hadn't fully worked out the implications of that when I was setting this up, but that'll get us by. So now I'm just touching my iron, which is 750 degrees, to my leads, and that's melting my flux. And that flux provides an oxygen barrier layer on the pins. And we do that because oxygen causes the solder to form up into little balls and not stick to our surface. So we're now touching our solder to our lead and soldering ourselves to the board. All right. That's sort of soldered in. It's not as good as I'd like it. But I'm going to block the camera here just to get on the other side of that. There we go. That's better. With this printed circuit board, the solder is our link to our physical and our electrical link to the board. It's what's going to hold the components on. There we go. And what we're looking for here, I don't know if this really shows up on the camera, we're looking for the solder to come down and attach itself to that little pad. And these pads are actually pretty large. Off camera, by the way, I am touching the tip of my iron into my flux. And I'm recoating it with solder. I do this to protect it from oxidation, because this metal at 750 degrees will oxidize. It'll get a black tip and it will stop taking solder. Now, if I did that right, I can pick this up and look at that. They don't fall out. They are electrically and mechanically connected to the board. That's what I wanted to see. Okay, so looking for our next piece that's pretty immune to me screwing up. And that's this little pad right here. That is where our little Arduino circuit goes, or microcontroller goes. We do this in two parts. We start with this little fellow right here. It's a socket. There's no chip in it. And this is what we want to solder to the board. And we do that because semiconductors, especially microcontrollers, really don't like heat. So I don't really want to solder right onto my microcontroller. Now, something that's really important here, let me use another component as a pointer. There's this little slot right here in the top that you can see. I want that slot to line up with the little U slot on the board that you see there. It's really important that lines up. That is our marker for where the top of the chip goes. The chip itself has a little dot on one corner, and the dot will go at the top of the board right where the slot is. And the dot, in fact, is will be at this corner. Okay, now I have to flip this over. I have to keep it from falling out while I do my soldering. I haven't determined the best way to do that yet. I'm probably going to shim something under it. And pros have better solutions to this. I am not a pro. I am an amateur with delusions of adequacy. Okay, so the usual solution for something like this is we're going to pin it in place. I'm going to actually use one of these glass beads. It won't balance perfectly, but it will work for my purposes. And I'm going to use this wooden block to shore it up on the other side. Okay, so that's, you can't see it on the camera, but that's got the pins pushed all the way through. And so I tinned that already. I put flux on these. All right, and in melting my flux, I managed to knock that off, so I am going to pin that on the other side too. Now it can't get away. Our little friend, the circuit board, is locked in place. There we go. So the usual solution when dealing with these multi-pin devices is we want to pin down one corner first. I'm going to grab this little square corner. This corresponds to pin 1. Not for any particular reason other than it's really convenient. Look at that. It's pinned down. Now it can't go anywhere. And now I'm just going to work my way down the board. And I'm going to solder each pin in. And I'm going to knock it off its precarious base. If anybody out there knows a better way to secure these boards so that my components don't go falling away because of gravity, I am very open to suggestions. bit of solder problem there. All right, there we go. Now, something that really helps and neatens this up is that purple there, something called a solder shield. The solder shield repels the molten metal. The little shiny metal bits, the copper there, that attracts the metal. The molten metal wants to bond with that. All right, so let me inspect that. It looks pretty good. Everything looks bonded. I might want to get a second pin that I did. Hit it again. I feel like that didn't get the full treatment. There we go. That's better. Yep, those are all good, happy, secure little solders there. They flooded out over their little pad and covered it completely. And so now my pad is secure. Now, if you look there, you'll see that I didn't, gravity was not my friend, and that was, it's risen up there a little bit. So I'm going to do something, I'm going to get underneath it, and I see I've got a solder bead there that's pushing it up. Okay. So I'm going to try to not singe myself. I'm going to get underneath that with a soldering iron. And I'm going to try to cause this to drop down. It seems rather optimistic that I'm going to get away with that, but I think it'll work. Well, I'm definitely transferring a lot of heat because my finger's getting really hot up there. I don't like that. Okay, I got a lot of that solder to go down there. Let's see if I can accomplish anything else. I don't think so. It's still a solid electrical connection, so I think I'm not going to worry about that. I think I'll let that worry about itself. Okay, next thing that we want to put on. My next least volatile thing. I have a resistor, this our little friend right here. And the resistor goes right here where it says R1. Now, these are simple devices to put in. We drop that in the hole. Pull it up. Oops, I'm doing that off screen, I'm sorry. Put that down there. I have to balance that out a little bit. There we go. I drop that right in. It looks nice and neat on top of there. Sticks up with great big pins underneath. So what I'm going to do is I'm going to use my thumb to push that tight against the board. Then I just bend these out away from the board. And that pins it in place and it can't get loose now. And that makes that a lot easier to solder. And we're just going to put a little bit of flux on that and a little bit of flux on that. There we go. Okay, I think that's in. Let me check that. Oh yeah, that's a good solder joint right there. Okay, then we flex these back up. And we take our shear cutters here. And we nip those right off. I don't want wires sticking out. There we go. Got those wires out of there. Now, our next least dangerous item. I've got a couple of capacitors here. I've got a 10 farad, microfarad, and a 47 microfarad. Now, these capacitors, they exist to absorb bumps in current. If we get a sudden current spike, like when you're connecting a battery or something like that, this will absorb it and keep it that spike in current from shooting through and frying things. So we have 2 of them. We put the big one between the battery, which connects here. That's where the battery connects. And the semiconductor that we're going to, which is going to be a voltage regulator that goes right here. Now, this type of, these barrel-shaped capacitors have a polarity to them, meaning there's a positive and a negative side. So this white stripe here with these minus signs in the middle of it, that's the negative side. And that corresponds to the white side here of the silk screen on top of the board. There's also a little plus sign on the board to mark the other side, just in case something happens that you can't see that. So the solution, the C1, that is where we put the 47 microfarad capacitor, the larger capacitor. So we push that all the way through, and just like we did with the resistor, we bend the tines over, and that keeps it in place. Now, at the same time, I'm going to do that with the 10 microfarad capacitor. And again, I'm looking for my little white stripe. It's sort of obscured by my finger there. That little white stripe. And that goes on the white side of the silk screen. And that goes through there. And we do the same bend the tines out sort of game. I just balance this between the 2 wooden blocks. Again, I will flux this. Now, capacitors have a little sensitivity to heat, especially this kind of capacitor, electrolytic capacitor. So we need to be a little careful. I'm not, soldering time doesn't take that long with these, so it's not really a big deal. But electrolytic capacitors react badly to heat, and they can explode. Loud popping noise, a bunch of ugly orange stuff goes spewing everywhere, and it's hot. You don't want to get it on you, especially in your eyes. So we are going to try to move quickly here. Look at that. That's sealed right up. There we go. How quickly that goes. And that comes from properly fluxing those surfaces and the tip of this needle, or this iron. That makes that go quickly. Okay, again, we bend our metal tines up. We're coming with our flush cutters. We get the wire leads off. We can't leave wire leads laying on there, it's bad. This isn't really a proper set of flush cutters. There is a tool that cuts much more flush. I recommend using that tool. You want these leads to be absolutely as short as possible. If they can be under 1/8 of an inch, under a couple of millimeters, life will be better. Every time there's something sticking up from the underside is an opportunity for, it's more opportunity for an electrical connection that you didn't intend to get made. Okay, look at that. We've actually filled all but 2 slots on this board. So we're coming along quite well. Okay, the next part that we're going to put in there is our voltage regulator. And that's this little friend here. It's pretty big. It's got this big metal bit on the back. That's a heat sink. I've got these 3 pins. Now, on the board where you see the 3 little rectangles there, those correspond to the side that the heat sink is supposed to be on. So we just drop that in there. And this device is a little different. So these are actually meant to be bent over backwards on the board. I'm not sure I'm going to do that with this board. They can be, but they don't have to be. Let's do that. I didn't really design this board properly to do that. The other thing to remember with these boards, there we go, he's down like that. You know, I don't like it like that. I'm going to straighten these back out. And by the way, you don't really want to do this. You don't want to go bending these pins around a lot, but you can do it once or twice and it's okay. So we're going to leave them tall like that. We're going to take these pins and we're going to bend them in opposite directions, just like we did with all of our other stuff. And there we go, that's secured. And now I can put this upside down. And I had to rest this up on the terminals rather than at the edges, just because this thing's taller. And we hit it gently with flux again, because we like our flux. It's cheap. It solves a problem. We like cheap solutions to our problems. All right, those are all fluxed. Sorry, let me move that closer to the center view of the camera. All right. And this is a semiconductor, so it's more sensitive to heat than other things we've dealt with so far. All right, there's our solder on that. There's our solder on that. Oops, our solder is giving us a little trouble there. Okay, that's more solder than I wanted, but it's not going anyplace bad. That's where that solder, that purple solder shield helps us. All right, that's that soldered in. We're making pretty good time. I think we're only about 15 minutes into this, and we're coming along nicely. 21 minutes according to my clock. Okay, just like before, we bend these back up to make them available. Well, that's pointy. So we get a tool underneath it and bend it back up. We do not like jamming that under our fingernails, not at all. It does not feel good. We get in there with our cutters and we cut off the little metal tabs. There we go. Everything's nice and flush. It's a little ugly down there from the flux, but overall that looks pretty good. Okay, we only have one last component to add on there, and that is our transistor. So here is our little friend transistor. If you look at him, he's got a flat side and a round side. That corresponds to the outline on there. And if you've never dealt with a transistor before, it's a form of indirection. So the microcontroller that goes in here, our little Arduino, can't really handle much current. But I need to put quite a bit of current and voltage out to the LED that comes out here. And so this acts as a way to getting, let's see, I'm stammering is what I'm doing. So this little line that comes in there, that's kind of hard to see on camera, but when you have a board in your hand, you'll be able to see it. That line comes straight from the battery, and that's going to run 9 volts. It can run pretty high current, and that comes in here on something called the collector. Out of, it's pin 6 on our Arduino, that runs out to the center pin on the transistor. That's called the base. And this line runs out here through our resistor and into the LED. That is called our emitter. So the way this transistor works, when I give a high signal to the base on this transistor, it lets current flow from the collector to the emitter. And so what that really means is I can turn this on and off as fast as I want and control this higher current. It was a long way of saying that it acts like a switch. So I'm doing the same thing here that I did with all of the other components. I'm bending the wires down to hold the transistor in place. And again, I balance this on those blocks of wood to keep it off my work surface. I flux it gently, or excessively in this case. I picked up a lot of flux that time. So we're just gonna melt that flux right down. Okay. And we'll solder that in. Now, transistors in particular are super sensitive to heat. I have personally let the magic smoke out of a lot of transistors. I nearly failed my high school electronics lab because of it. Alright. Oh, that looks good. I think that's solid. Uh-oh. I think that's bad. Alright. I have... Hey, that's warm. That's not good. Looks like some bridging going on down there. I don't know what it is. Alright, I have something that's filling the gap between two things. I do not like that. And I need to know if that's metal or if it is just some flux that ran down there. That's really, really important to know that. Know the answer to that. I want to see if my knife point's fine enough to get in there. I don't think it is. This is not my fine point knife. My knife point is not fine enough to get in there. I doubt you'll be able to see it, but try to have a look down there. You might be able to see a little gap in between there. If that gap is solder, that is bad. Alright, let's try. I can actually see now that it is not solder because I can see through it and solder is opaque. So that's good. All right. Flux is non-conductive, I believe. I hope. We'll find out. This is a good case for using a non-conductive flux, or a liquid flux, by the way, rather than a paste flux. Liquid flux will not solidify and bridge gaps like that. Okay. All right, so that is the board assembled, and timer says we are at 27 minutes, so we did that in half an hour. That is wonderful. So now we need to assemble a couple of other things. The board is assembled. I'm just going to set that aside. Well, first I'm going to trim those pins. Okay, those pins are trimmed now. So I'm going to set that board aside, and we need to assemble our LED. So when we do this workshop, you're just going to get a pair of these little, they're red. I'm going to ship red LEDs unless somebody requests something different. So I'm going to have to clean up some of my mess here. All right. Okay. So these are supposed to be glowing eyes in our pumpkin. You can also do a plastic rat or something like that. We'll work this into it and put these in for the eyes. But you'll get a pair of little LEDs like that. If you look at those, you can see that one pin is longer than the other. One pin is the negative line, and the other pin is the positive line. So what we want to do is look up, I never remember this, LED polarity. So fortunately we always have our phones. Phones are super helpful. So the long line is the positive line and the short line is the negative line. Now we're going to color code that. Traditionally the negative line is black or white. We want a neutral color. I don't know how long this wire needs to be because I haven't actually built the pumpkin properly itself yet. So I am going to make these, oh, that looks like a solid 9 inches. So what I'm using here, this is this is solid core bell wire pair. You can buy this at any hardware store. They'll just have it listed as bell wire. And it'll always be 2 different colored wires. So what I'm going to do, I'm going to cut that off. I'm going to cut those the same length. And I'm going to measure out another set that's the exact same length. And I'm kind of off camera here, I'm sorry. So there's my 2 wires. And then I want to get another short section. I made these kind of long so that the eyes can be far apart if they need to. I don't know. It's probably ridiculous, but that's what I did. I'm going to cut another shorter section. And the way this works, by the way, this is a tool you'll definitely want to have, a wire cutter. Wire cutters it's going to make it easier to strip the wire and cut it neatly to length. Much better than a pair of pliers with a wire cutting extension. So the first thing we're going to do is we really need to solder these to our LEDs. And so I'm going to strip off, this is a 18 gauge wire. Well, I'm going to strip off, that looks like a solid 1/2 inch there, maybe 3/4 of an inch. Got that. That is about the same length as that short lead. That's great. That's exactly what I want. Now, let me get the same length of wire stripped off over here for the other one. And I'm going to do the same for the colored lead. The color side is going to be the positive. Which goes to the long lead. Now, this is a solder joint, and solder joints aren't very strong. So I've got something called heat shrink tubing, and every hardware store carries this. This heat shrink tubing is going to strengthen the joint for us. It'll provide mechanical strength that the solder won't. Now I'm going to dip all of my wire leads into flux because I want good oxygen-free connections so that the solder doesn't come rolling off. And I'm just going to take this opportunity to melt the flux right now. Okay. That's melted. Now, let me pull all of this stuff aside. So, I don't need really long lengths of this heat shrink tubing. I just really need it to cover up the length of these leads where the 2 parts overlap. So I'm going to cut it just slightly longer than that. And this cuts with any ordinary pocket knife. It's pretty easy material to work with. Let's try that again. So we cut it just longer. I'm going to need 4 pieces for this. Okay. I need to open up my other box of heat shrink tubing. You can get this in lots of colors too if you like a more colorful project. I guess I'm going to cut 2 longer ones and 2 shorter ones. There we go. Comes in lots of colors. Black is really common because it sort of fades out of the way. I'm using white because it's what they had at the hardware store when I needed some. And I've honestly just sort of stuck with that all these years. Now, all right. The way to make this work, and I'm going to set those short leads aside. Got enough going on here with the long leads. Our white wire goes to the short lead. And the first thing we do is we slide our heat shrink tube down over that. Oops. Let me not wedge all that stuff in there. So to make this work, this is kind of a jury-rigged affair. I'm going to pin that down with a little weight. And I am just going to slide my, even though I like these wires to stay paired, I'm going to pull the white wire out of there, or the white and the black wire out of there. Now, I'm going to put these next to each other, and it's super important that that wire be straight. It has to be perfectly straight to match with those pins, because if it's not straight, they're never going to get together. And so what I'm going to do is I'm going to take these needle nose pliers, and this looks pretty straight, but there's just a subtle bend to it. So I'm going to use these needle nose pliers to straighten that. And see, now that's little kinks out of it, and I rotate it 90 degrees, and I take another kink out of it, and all right, sort of manipulate it a little by hand, and that's pretty good. Now I want my solder in there just ready to go. So what I'm going to do is I'm going to melt a little bit of solder right onto the LED. I'm going to try. It doesn't necessarily seem like my greatest skill. I'm having a little trouble making it happen. There we go. Okay, I've got just a little bead up there, and that's all I really need. As long as I'm there, let's do the same for the other one. There we go. Now, it's tended to bulb out and form little bridges and whiskers, and we don't want that. We also don't want it to go rolling off, determining its own destiny. That will never work. We need it to park itself right there. Again, we're going for the short lead, and that's the one closest to the camera right now. And we're just going to put these two right next to each other. I'm going to touch the iron to it. Get a little bit of solder to join the two. Oops. This part's really tricky. And I'm not going to lie, I've taken to using pre-wired LEDs. And frankly, it's made my life a lot easier. Okay, we're going to take some of this out. We're just drawing this out. Should not do this with an unsupported LED because weird stuff happens. And by weird stuff, I mean that the LED and the wires start to go in slightly different directions. And that is very inconvenient. I do not like it. Okay, that is, it seems to be pretty solid. I'm gonna flex my wire a little bit. There's gonna be a little bump in it, but that's okay. And with that pinned in place, I can take a little bit of solder and where's my solder? Which is of course supporting that, which isn't really ideal. I'm just gonna pin that down with the cutter again. We're gonna try really hard to pin that down with the cutter. Sorry, I've got this turned away from the camera a little bit, but I have to see to get in there, and I'm just gonna put a little blob of solder there. see how that's going. Alright, that's bubbling up right there, which isn't where I want it. I want it down in there. There we go. Alright. So hopefully you can see that. I've got a nice little bead of solder that's sort of run all along it. It's made a solid joint. There we go. Yeah, that's nice and neat. That's exactly what we want. Now, I'm having some problems because this tip is getting dark. You can see here. It's oxidizing. And so this is off camera, but I have a little brass Brillo pad next to my workstation. It's part of my solder station. And so I am retinning my tip, which means that I cleaned it off, cleaned all that oxide off, and dipped it in my flux, and that really did just clear, all that black stuff went away. Put a little solder on it to recoat it with solder to remind it of what the magic is, and life is good. Okay. I need to do the same sort of cleaning and preparation for the red lead. So again, I'm just going to grab it with the pliers, rotate that 90 degrees, get it around. Yeah, nice and straight now. It's excellent. Looks like there's a little bit of unmelted flux on that, so I'm just going to touch it with my iron. When you're working with a solder iron, always keep an eye out for that blackened tip. If you're having trouble soldering, that blackened tip is probably the root of your problem. It just means you need to clean it. Clean it and reflux it. Okay, I'm going to use, for the positive line, I'm going to use a longer tube. I don't know that it matters. It's just what I'm choosing to do. And just like we did with the white wire, our negative wire, we're going to lay our positive wire right next to the lead here. And I'm going to transfer some solder. Remember, I pre-soldered that tip, that lead on the LED. Okay, look at that. It melted nicely. That was beautiful. Sorry, that's happening off camera, but or on the side away from the camera. But look at that. A beautiful line of silver solder there. Some of that's hard to do with a regular soldering iron. I'm using a solder station, and if you take my workshop, I'm going to strongly recommend you buy a solder station. They're about $40, $50. This one cost a little bit more. This is a nice Hacko station. But I've been doing this long enough to know that I wanted good tools. Okay. And so we can slide these up, and I don't want to pull my heat gun out right now. I want to wait till I've got the other tube done, the other wire done. But then we'll just pour a heat gun on this, and we'll just see that shrink right up, and it'll seize up right around our LED. It'll be wonderful. So I'm just setting that off to the side. And I'm going to repeat our work here. I wonder if this might give me a better experience. No, that won't. Okay. I'm going to use it to pin that down anyway. Nice rubber grip on it. If nothing else, will probably make my life easier. So, just as a precaution, I'm going to flux these two. Oops. I will not put up. Again, I'm going to find a good source for the workshop. I'm going to find a good source of liquid flux. It's just a lot easier to work with than this paste flux. This paste flux is meant to be used with plumbing, and pipes don't move. I mean, they're pretty heavy, you know. This thing is light, it just bounces all over the place. Okay, so that's been fluxed. And now we will tin it. Nice tin job on that. Let me prep my leads. And that's actually really straight. The straightening is just kind of a formality here. I'm going to do this. I'm going to keep the order the same. Consistency is really important when you're doing fussy little work like this. It's really easy to lose track of what you're up to. Okay, so again, white goes to the short lead. White wire to the short lead. And I got a nice solder coating on that wire, but I didn't get enough to form a good link. So let's try option 2, which is get a nice solder bead on the wire. There we go. It's a lovely solder bead right on the wire. That will be very hard not to attach. All right. Having a slight problem here in that I keep pushing the wire away. So I'm just going to flip it over. I don't know if that'll get me anything or not, but it's worth trying. I think that did it. That did it. Well, that's actually a beautiful joint right there. Maybe not as close as I could want it, but it's close enough. Okay, I want to fill that in just a little bit to strengthen it. I have to. One of the advantages of working with wire, it's tedious and fiddly, and it like gets in your way a lot, but it's bendable. I can bend it to do what I want. All right, now I'm bending it to hold still so I can see it. All right, now I can get down here over it. Okay, that's good. Now, the astute observer will notice that I actually lacked a little bit of consistency. If you look at this wire, at no point do you see a heat shrink sleeve. So we're going to slip that heat shrink sleeve on there where it was supposed to have been. And now, based on my experience with that last wire, I'm just going to pre-tin this wire. I think it'll just make my life easier. Look at that. Got a nice little shiny silver line of solder all the way up that. That's going to make our life a lot easier when we go to attach ourselves here. And I want to pin that down there. And I want to discourage it from running away. And I want it to support itself so it doesn't try to pop up. Okay. So we're like that. We're going to be clever monkeys and we're going to put our heat shrink tube on before. And because the heat shrink is open at the other end, it doesn't matter that much. But these are going to get tied together as one thing and I don't want to slip up. These two LEDs are going to get tied into one wire later on. If I forget to put that sleeve on before then, I won't be able to get it in. Alright. So now we are soldering that. We are moving it while it's still hot and the metal isn't holding yet. Look at that. Okay. That's good. Now, when you do this, don't be surprised if that part is frustrating. The first time I did one of these, I wired an LED in. It was a very frustrating experience. I did it a lot. I used all the good words, the ones that it usually takes a stint in the Merchant Marine to learn. All right, and I just managed to undo it because I was fooling around, and my wire got too much corrosion on it, too much oxidation. So we're gonna melt down these high spots and do this again. Okay, it's secured there. Let's pin that end and we'll fill it here. We're looking for nice smooth lines. We don't want bubbles. There we go. Good smooth lines. I didn't push it too far. I was close to doing it too far there. Okay. And so now, to confirm that this is good, we can slide these sleeves up, and they go all the way up. They don't catch on any burrs. All right, would you look at that? So we have two LEDs with sleeves, and we're ready to heat shrink. I have to warn you, my audio is about to get horrible. Because a heat shrink gun is really just an overpowered hairdryer. So the audio is about to get atrocious. You can do this also with just a lighter. I don't have a lighter, and I'm in a woodworking shop, and so I'm not real hip to open flame in here. So we'll try to demonstrate this on camera. Excuse me as I lock a thing in there in case something goes bad. But we'll try to get it so you can see these shrink. Look at that. It's snugging up really nice. It'd be hard to hear me over the dryer. So snugged up nice. There's no opportunity for unintended electrical contact. Trust me, without this, you will get unintended electrical contact. All right, enough with the white noise generator. I have to step away for just a minute. Set this down in a safe spot. Again, wood shop, really, really sensitive about hot things. Okay, that looks great. I love that. Two nice, neat little ends there. So we need to strip the other end as well. I want to strip more there because I'm going to try to make a solid mechanical connection. So I've got about an inch. I'm going to strip that. Okay, so those are those ends. And now I want to do the same thing. These are the short leads. These are what I'm actually going to connect to the board. I want to do the same with those. On one end. I only want to strip them long on one end. There's one. There's one. And I want to do a short strip on the other end. I want it to be under a 1/4 inch, maybe just about a 1/4 inch. I'm going to take it down to just less than a 1/4 inch. I just need the bare tip of it. And you don't want more than that. And that's because that's all we can put inside of the screw terminals. I don't want any wire sticking outside of the screw terminals. So nice short little nubs there. Okay, and all that fussiness that we had at the other end about keeping everything straight, we aren't doing any of that here. We're taking, this is a little harder to show, but I'm taking my 2 long ends, the ones that are connected to LEDs. I'm taking the white wires, and I am twisting them together. Again, one twist, and then I'm going to slide this in. And I'm going to twist everybody around each other. I'll twist that one around the outside. There's probably a more elegant way to do this. I don't happen to know it. It's frankly made kind of a heck of a knot there. I want to get one of my heat shrink sleeves over that. My heat shrink sleeves might be too thin to go over that. I'm going to try it, see what I get. Fun fact, these heat shrink sleeves are not super bendable. That's getting worse. I actually need to take my pliers, the tips of my wire cutters, and I'm going to straighten those back out. I'm going to try to. This frankly could be a good case for an automotive crimp connector. Little red tubes with wire on the inside, and you shove these wires inside that tube and then crimp it down. I think this wire is too fine to do that with effectively. But this is a part that's going to get moved around a bit. Kind of need it to be a mechanically strong connection. So that whole thing where you thought maybe I knew what I was doing because I was running this video, I hope we have successfully dispelled that horrible myth. Okay, that's straightened out. Let me straighten this one out a little bit more. Okay, and this one I need to re-straighten. What we're going to do exactly like we did connecting the LED. We're going to lay them next to each other. Good layer of solder on each of them already. I'm going to solder them together. It's not where I wanted to be with this, but it's where I am with this. And second, I have a little more straightening to do on this end. It's not as straight as I could want it. Okay. Again, I'm laying the two LEDs down next to each other. They're like that. And we'll just lay this right in between the pair of them, and we'll solder them together. There has to be a way to make this better. I'm gonna try this. I'm gonna hold those two there. We'll just twist them around each other and see how that goes. All right. Straight enough, I can slide the shrink wrap sleeve over it. So I think we're actually in a good spot with that. I'm going to use the full length shrink wrap sleeve for this just because I think that's important for strength. Okay, and I want that soldered. Too many opportunities for this to go awry here. So we flux it. Drop a block. It's a wooden block that I was using to prop things up with. Just drop down below the desk for the workbench. Okay. That is down there. Let's get some solder in there. Let's try. Hard to see this on camera, but it's actually, the solder is actually traveling through those joints quite well. You're starting to see a nice silver layer show up there. Okay, think that's good. Okay, slide our olefin sleeve over it. This heat shrink material is olefin. And it's actually hot enough it's shrinking the sleeve over the top of it. Isn't really what I want, but it's what I'm getting. All right, so don't do that. Let it cool before you bring them together like that. But okay, I'm going to do the same thing here with our red wires. These are the positive line. I'm going to strip this back just a little bit further than I did initially. The extra length of wire is good for building that mechanical connection. So those two are there next to each other, and this one is coming in from the other direction. Pardon me, I'm knocking everything off of my workbench today. So we'll start by wrapping those around each other right there. I'll just go on down there. Bring that up flat there. Those, another twist around. There we go. All right, it's not very pretty, but I think that's going to work pretty well. Grab another heat shrink tube, and from looking at what happened with the last one, I'm still going to put the whole sleeve on it. So we slide it up there. We're going to test it to make sure it goes over it. And it does. Okay, it's beautiful. Now we're going to let this joint cool after we solder it. Now, you can tell I wasn't an electrical lineman because they would insist on a Western Union joint here. It requires several more inches of wire but they're really strong. All right, so flux the life out of it again. Get our, melt some of our flux. Oh, I'm sorry, that all came apart. I have to re-straighten that wire and do that again. Don't want to do this too often. The wire does not like to be bent often, it breaks. If you flex it too much. We do not want our wire to break. It will be very inconvenient. We'll have to try to measure out another length that's the same length. It will not work well. We want our wires to stay about the same length, otherwise it becomes very difficult to manage it when we're building our decoration. We want them the same length. Otherwise you wind up with a loop of wire that's running around in there. And a lot of times inside of a Halloween decoration there's not a tremendous amount of space to deal with a stray loop of wire. So we're going to avoid that if at all possible. Okay, that's crimped down flat. Okay, so let's try that again. I'm going to twist this pair. We'll bring them back together. We'll twist in this other pair. Okay, not perfect. That's what we got. Again, we're going to flux it. And we're going to apply solder generously. Okay, that's very generously soldered now. let that cool just a little bit. Then we will slide our olefin sleeve over it. There. Pinching down a thing that stood out just a little bit. All right, well that's cooling. Actually done with our soldering for the night. So I'm gonna power down my soldering iron. One less heat source running around in a workshop. All right. One of the tasks that we have to do is program our device. And so I'm going to show you what that looks like. If you've used an Arduino before, you've seen the bigger ones where you can hook a just a USB cable up to them. But this Arduino is just a chip. It's just a bare little chip. And so we need to program it with a programmer like this. And this is a little, plugs into the USB port on my computer. And it can program it. Instead of using a serial interface, which is what most Arduinos use, these ATtinies use something called SPI. So it's faster than serial, but takes a little more specialized hardware than the serial does. So these pins are deliberately flexed out just a little bit on this so that whatever you insert them into, they get a good grip. Now, I don't know if you can see it on camera there, but there's a little dot on the top of that. I'm lining that dot up with the top of here to correspond with that little notch. So I'm going to slide that in there, and I push it back ever so gently to get the others in the socket. And then I push that down. It's seated well. So looks like that. I'll put that back in my USB port on my computer. And I'm going to take just a minute here, and I'm going to switch the screen view over to our Arduino view instead of that camera. So yeah, our workspace. Okay, just pulled the programmer out. Now this step's a touch delicate. I have to get that chip out of here without bending anything. Typically I like to just stick a knife under it. Really important to pull evenly. So, okay, that came out. Nothing significantly bent. That's good. Sometimes that can be difficult. So we're just going to set our programmer aside, and we're going to pull our board back here. And with our board back here, I've got my little, sorry, that's not a good pointer. Right there is my dot. Right there is the little divot inside in the top of the chip holder. So we're going to put it in there. And this is where I often run into trouble. I need to insert all of these pins with a nice even force. It's really easy for one side to refuse to go in. Pins will get bent at a funny angle. If that happens, you have to pull it out and carefully straighten the pins, and it's not any fun. And it's doing it a little bit there. We're rocking it in, and that chip is seated. I could probably go down further, but I don't see the need. If you look very carefully down there, you can see it. You'll be able to see down through the bottom, and there's a gap, but there's a solid electrical connection, and that's all we need. Okay, so that's our chip mounted on there. It's been programmed, it's been mounted. In theory, we could pull it out at some later point and program it to do something different, but again, you really don't want to pull those out too much. You kind of want to get the program right on it the first time, because it's a delicate operation and you risk bending your pins. Okay, so the next operation we need to do is just hook some stuff up. Now, there's one thing I'm not going to do tonight, and just because I don't have the parts with me. Normally there's a switch that would go on here to control whether this is on or off, because otherwise disconnecting the battery is a nuisance. Tonight we're going to fake the switch out by just running a loop of wire across the end of that. But we have other problems to solve first. One of those problems is I'm missing a small screwdriver. I was looking at it in my toolbox. I obviously didn't bring it with me. I'm feeling really special about that, but I've got a lot of screws to twist here. So I'm going to go AFK for just a minute. I will be back with the screwdriver. And in fact, before I go AFK for that, let's do our shrink wrap game down here. That joint's cool enough now that I can cover it. So, sliding my shrink wrap tube up there. I've got that spread out pretty well on either side of that. So that's that. You may hear my cat has come to join me. That's Aiden. He's always happy to be in the workshop. That happiness may end as soon as I plug in the heat gun. Okay, shrink this tubing. It's kind of masking the sound of Aiden meowing at me. He wants me to come upstairs and watch hockey. Stanley Cup playoff finals going on. He's a big hockey fan. Alright, I set this on high, so that's shrinking up a lot faster this time. I don't always like to use the high setting. The high setting can interact badly with some components, like electrolytic capacitors, but we don't have any electrolytic capacitors handy here. Electrolytic capacitors are those blue barrel-shaped capacitors that you just saw me slide around. Okay, that's our shrink wrap settled. I'd put the cat on camera, but the viewing stage is actually really small here. Okay, now these ends, here, these bare wire ends are kind of a problem. I could make them work, but I don't want to. I'm going to use something called a wire ferrule. And you can buy these kits. I just ordered them on Amazon. And these, I think, I was probably going to use a gray. Let me see. Let's see if that slides in there. Yep, okay, that slides right into the tube. So the way these work, and I guess I want to cut a little bit more out. The way a wire ferrule works is it provides, just like the shrink wrap does, for the bare wires, this provides a strengthener for the tip of the wire. I want to strip these down to be about the same length as the metal portion of this. It's a metal shaft with a plastic collar on it there. And that just provides a better gripping surface on the wire when you're putting it into a screw terminal. You can see those ferrules come in all different sizes for whatever your needs are. So we slide into this, and this is a special crimper. It's got sort of a hex pattern going on there. So we're going to slide it in there, pretty much to the base of the metal. And we'll crimp it down. And so that's got a good grip on there. I can't push that off easily without breaking the wire. Now of course, I only pulled out one ferrule. I needed two, so we're going to go back and get another ferrule. Especially if you're ever working with stranded wiring, you have to make connections to a screw terminal. Use ferrules. This solid wire would probably be okay. This is just me being paranoid. When I ship you your kit, some of the components do use the battery clip has stranded wire, and I'm going to ship it with ferrules already attached because that stranded wire just snaps. The first Halloween animatronics I ever made ran perfectly in the house. I tried it out a bunch of times. What I didn't know was that it was creating stress on the battery wires, and it ran for about 1 second when I finally put it outside for Halloween, and then the battery connection broke, and it was very sad. So try not to do that. So there's my ferrules. This is my LED end here. And this doesn't show up on camera, but there's in the copper underneath, it says LED, and there's a plus here and a minus here. If you remember from when we were assembling these, the minus is the white wire. So that just goes in there, and we'll screw that down. This is where I have to go AFK. I'm sorry about that. I'll be back in just a moment while I step out and grab my wire cutters, or my screwdriver. All right, I'm back. All right, this is just a cheap little mini screwdriver kit. I bought this at the hardware store. Most hardware stores have something like this. Absolutely worth having. It'll make your life a lot easier. So we're just gonna tighten that down. And we're gonna put the ferrule back in there. We'll tighten the screw down. I don't know if you can see it grabbing it like that, but it got a good grip on it. Do the same for the other wire. Yeah, another good grip. Look at that. Now those aren't coming out. I'm tugging on those. They're staying solid. So that's good. And we've got our battery clip here. We'll do the same. The battery clips work the same way. The negative pole is the neutral color, so the black. The colored wire is the positive. And on this board, I've also marked out a positive and negative. So it'll line up like this. There's a positive and a negative in the copper. All right. Now, positive side, on the battery's already got a pretty good grip on something. I need to get it to let go. So I'm just going to back those off. All right, now I should be able to put that in there pretty well. There we go. That went in there nicely this time. Okay, so those are seated pretty solidly. All right, they won't come out now. And this one is super, super important because you've got a 9-volt battery dangling off the end of it. And that 9-volt battery just adds a lot of weight to it. It's something that can definitely get, it could yank something out. Okay, so that's there. Now I need to cut a little length of wire to act as my switch. It's not great, but there's my switch. And we'll strip off a tiny little bit off of each end. When I ship you the kit, I'm actually going to ship you a proper toggle switch or a rocker switch. It'll be something that's pretty stable and reliable. Let me sure, a switch is more involved than you might think. All right. Okay, so I connected it. Let me disconnect it and put it back in. Okay, if you look at that, our lights are coming on. That is exactly the action we were looking for. If I take that out, you'll see it slowly fading on. That's wonderful. That is exactly the action we were looking for. That's going to stay on for a little bit. I'm sorry, those aren't on screen. There they are. They're on screen. Let me show it again. All right. You see, and they just faded in nicely like that. That's exactly the effect we're looking for. Now, you saw the source code up there before with the programmer. You can go in and change numbers in there, and it'll change how long it takes these to come on, how long they'll stay on. And it is somewhat randomized, but as far as when they come on and off, but how long it takes to fade in and things like that, that's not randomized. There they go. They faded out. Now, to make sure I didn't just let the magic smoke out, we'll bring them back. Look at that. Fading right back in. Exactly what we want. Okay. Well, folks, I want to thank you for watching this video. It's been great. And if you've got any questions, feel free to put them on the comments below the YouTube video. Thank you.